Today I'm going to be talking about solving linear systems using technology. And what's really nice about this is when you are solving linear systems by hand, you actually can check your answers by using your calculator. So I'm going to show you how to do this. Okay, so the first thing we need to know is how to write an augmented matrix for the system, and then to state the dimensions. And we do that by row, by column. So number one, if we notice, is 5y minus 4x equals negative 7, and 3x minus 7y equals 15. Well, when we do an augmented matrix, we have to make sure our variables go in alphabetical order. So we're going to have to reorder this system to be negative 4x plus 5y equals negative 7, and let's just write down the other one so we have it. And now an augmented matrix is when we write down the coefficients and the constants in a matrix. So it'd be negative 4, 5, negative 7, 3, negative 7, 15. And this is our augmented matrix. And this is going to help us enter our information into our calculator. The other piece we need to know are the dimensions, and we do this by row, by column. This matrix has 2 columns and 3 rows. So this is a 2 by 3 matrix. All right, now let me show you another example, and this one has 3 variables. But if you notice, in the first equation, we only have an x and a z. So when this happens, when we write our augmented matrix, we put 5 for x, but we need a placeholder for y. So we're going to put a 0, then 2, and 9 is our constant. So then let's continue with the next row. 3, 5, negative 8, 15, 4, 2, 9, and 11. Okay, so, and this is what we're going to input into the calculator. So we've got to know how to properly write that augmented matrix. And the dimensions of this matrix is a 3 by 4. And that's going to be important when inputting into the calculator as well. Okay, so now what I'm going to show you next are the steps. Okay, so you always can go back and forth and look at these steps or look at them while we're putting these into the calculator. But I'm going to go to the big calculator so you can see how this is done. Okay, now before I go to the big calculator, I'm going to use number 1 for our information. So let's write an augmented matrix for this first system. So we're going to have 1, 4, negative 1, negative 7, 2, negative 1, 2, 15, negative 3, 1, negative 3, negative 22. Okay, and we've got a 3 by 4. So these pieces of information are going to be put into the calculator. So I'm going to follow these steps that I put on before. Okay, so let's go to our calculator, and I've just turned it on like regular. And the first thing that I'm going to do is I'm going to push second x to the negative 1, which is matrix. Okay, and once I've done that, I'm going to arrow over to edit and push 1. And now this is where we put our information in. We're going to put in our matrix dimensions and the elements, the numbers that we've done. Okay, so our dimensions for our first matrix is a 3 by 4. And if you notice, once you push enter, you do 3, enter, 4, enter, it gives us our matrix. Now there isn't the 3 dots, but that's fine. We're just going to follow along by rows. It goes by rows for this one. So we're going to put in 1, enter, 4, negative 1, negative 7. And if you notice, it puts in our first row, and we just keep on going. Let's do 2, negative 1, 2, 15, negative 3, 1, negative 3, negative 22. And when you put in your negative 22, make sure you push enter to make sure the whole matrix is complete. Now once we've done that, we want to go back to our original screen, so we're going to push second mode to quit out. After we've done that, we are going to go to second matrix, arrow over to math, and we are going to go down to the B selection and select RREF. And this stands for Reduced Row Echelon Form. And I'll explain that a little bit more when we get here. So we're going to select this. And in our screen, it pops up RREF in a parentheses. Now we have to put our matrix inside of this. So to do that, we do second matrix. And we push 1. If you notice, we have the 3 by 4. That means we have a 3 by 4 matrix saved there. So we're going to push 1. So matrix A is going to be reduced row echelon form. That's the calculation that we're going to do in the calculator. So we're going to push enter. And this is the reduced row echelon form. If you notice, there's a 1 for the coefficient for x, but 0 for the y and z, and then a 2. So we're going to rewrite this into a system. So the first column is x, second column is y, third column is z, fourth column is your answers. So this is going to be x. Let's put it beside the column so you can see it. This is going to be x equals 2. This one is going to be y equals -1. And this one is going to be z equals 5. So this gives us our answer, our reduced row echelon form. So now we can put in our ordered triple for our answer. So it's 2, -1, 5. All right. Okay, so what I'm going to do is I'm going to show you number 2 because it's very important to see what happens when we put this into the calculator. So I'm just going to put the augmented matrix and the dimensions into my calculator. So I'm going to go back, and to do this, I'm going to go back to my matrix and I'm going to edit. So I'm going to do second matrix, arrow over to edit, push enter. And the matrix dimensions for number 2 is still 3 by 4. And then I'm just going to put in my elements on top of the old one. So that's going to be 1, -2, 3, -9. 2, 5, 1, 10. And our last row is 3, -6, 9, and 12. Okay, and once we've done that, we go to second quit. And once again, we're going to go to second matrix, arrow over, and we're going to select our RREF. So we're going to go down to B, RREF, and then we're going to select our first matrix. So we're going to do a second matrix, 1 to get that new matrix, and enter. Now, if you notice, some weird things are going on here, and we have decimals, and it doesn't have a bunch of zeros where we think it should be. So first thing we're going to do is I want to turn these decimals into fractions. So I'm going to push math, enter, enter. And this gives us fractions. Now, when we get something like this and you go, wait a second, something seems weird, let's rewrite our system from the reduced row echelon form into actual equations. So remember, the first column is your x's, so that means the x has a coefficient of 1. So we do x plus the third column is z, 17/9 z, and it will equal, and the last one is our constants, our answers, 0. So that's our first system that we get. Second one is y minus 5/9 z equals 0, and our very last one we have 0, 0, 0, so we're going to have 0 equals 1. And if we see that, just like we've done before in systems of equations, this is a false statement. And if we have a false statement, it is a no solution. This is a no solution right here. So that's what it looks like in a reduced row echelon form. If you're not sure, put it into an equations like you usually see. If it's a true statement, it's infinitely many solutions, and if it's a false statement, it is no solution. So I want to make sure that you got to see that so you weren't confused if you got something kind of weird to you in your calculator. Okay, so for number 2, we got a no solution.